Hello, good morning to everyone. I am Professor Krishnananda, Head of the Department of ECE, Government SKJT Technological Institute, KR Circle, Bangalore. Today we will discuss about the addressing modes of the 8051 microcontroller. So the learning objectives for this particular topic would be listing the addressing modes of the 8051 microcontroller and distinguish between different types of addressing modes, and also able to understand and identify different addressing modes and their usage. Along with that, we also would like to see that how to use or access the internal and external memory using the different addressing modes. Along with this, we also look into the special function registers of 8051 and how to access them. So let us start with the basic definitions. The addressing modes come under the category of programming model of 8051, which has three different aspects like instruction formats, addressing modes, and instruction set. So addressing mode actually refers to the various ways of specifying the operands for an instruction. And addressing modes are actually designed along with the architecture of a microcontroller, so we are not able to alter it during our programming techniques. The 8051 provides a total of 5 distinct addressing modes. They are the immediate addressing mode, the register addressing mode, the direct addressing mode, the register indirect addressing mode, and indexed addressing mode. Let us come to the first one, the immediate addressing mode. In the immediate addressing mode, the operand or the data is given along with the instruction itself, and to indicate that it is a data, we also precede the data with the pound sign or the hash symbol. That means the source operand in this instruction is a constant. So the major advantage of this addressing mode is whenever we know the value of an operation, immediately we can give it in the instruction itself. So some of the valid examples of the immediate addressing mode would be move a comma hash 25h. That means you copy a value 25 into the accumulator of 8051. Only one constraint we have here is the destination of the instruction cannot be the constant data. Only the source can be the constant data. So you can copy the constant data into a register or memory, or you can add this data to a register like accumulator. So all these examples would be valid for immediate addressing mode. Now let us come to the register addressing mode. In the register addressing mode, both the source and the destination operands of an instruction would be registers. The source and destination has to be registers. So in this case, the operation would be like copying data from one register to another. Like for example, move a comma r0 would copy the value available in r0 register to the a register or the accumulator. Similarly, if you try to write add a comma r5, it will add the contents of register r5 with the accumulator and stores the result also in accumulator. So one caution to look into this particular mode is we cannot copy the data between any two registers like r1 comma r2 like that. One of the register, that is either the source or the destination, has to be the register A. And another caution to look into this mode is the source and destination register must be of the same size. Now let us come to the different ways of accessing the memory using different addressing modes. As we know, in 8051 we have around 128 bytes of internal memory, that is RAM, the data memory, where the address has been designed from 00 to 7F. So if at all the data is available in any of the memory locations, how to access it? Now another way of putting the data is in external memory as well, which is outside the 8051 chip. So we need to know how to access the data available in internal memory as well as the external memory. So there are three addressing modes possible in 8051 to access the memory data, which are called as direct addressing mode, register indirect addressing mode and indexed addressing mode. So you look into the first of them, the direct addressing mode. The direct addressing mode is useful when data is available in internal RAM. Most of the times the data is available in the locations 30 to 7F, and the register bank locations can also be accessed using the addresses like 0 to 1F. So the source or the destination or both can be memory addresses in this particular addressing mode. The example, for example, if we write move R0, 40H, it means the copy the contents of the memory location 40H into register R0. Or if you write move A, 04, it means copy the content of the memory location 04 into A, which is same as saying that copy the register value R4 into accumulator A. Now, if you want to access the special function registers of 8051, the list is given here. So there are a lot of special function registers available in 8051 like A, B, PSW, port 0, port 1, TMOD, TCON, etc. All of them would be accessed using their addresses. The address ranges between 80H to FFH. So we can use the direct addressing mode even to access the special function registers. Another use of direct addressing mode is to operate on the stack of 8051. So only direct addressing mode is allowed to operate on the stack, like using push and pop operation, that we will discuss separately later. Now some examples are shown, you can as well go through that. Now coming to the register indirect addressing mode, this mode is useful when we do not know the exact address of the data. So that means here we use the concept of pointers. That means a register will hold the address of the data and address of the memory where the data resides. So this is known as indirect addressing. So the pointers can be only registers R0 and R1. R2 to R7 cannot be used as pointers in this particular case. So the syntax would be like move A, at R0. So the at symbol is used to indicate indirect addressing. That means R0 holds the address of a memory location. From that location you copy the content into A register. Move A, at R0, like that. So register indirect would be very useful to allocate memory dynamically, as well as to operate on looping instructions. Similarly, if the data is relocated, we have to change only the starting address so that the total code need not be modified again and again. So the last addressing mode we would like to discuss is known as the indexed addressing mode. In the indexed addressing mode, we normally try to access the external data memory or the external code memory or the ROM, or read-only memory space. So we have two separate instructions for this particular addressing mode. One is like move X and the other one is the move C. Move C is the one instruction which actually is able to read the data from the external program memory. The syntax would be something like this: the move C A, at A plus PC, or move C A, at A plus DPTR, where DPTR and PC are the 16-bit pointer registers which can hold the address of a memory location. So in these kinds of examples, what is generally done is A is used to as an offset into the memory, and A plus DPTR or A plus PC together gives the memory address of the external memory. And then from that an 8-bit data is copied again into A register only. That means destination has to be A register or the source has to be A register. No other register can be used in the indexed addressing mode except A and DPTR as well as the PC. Similarly, in the move X instruction, only DPTR can be used to hold the address of the external memory. For example, if you write move X A, at DPTR, you will copy the data from the address pointed by DPTR into the A register. So these are the 5 different addressing modes of the 8051. So all of you should be able to read through the syntax and try to note the differences between different addressing modes, as well as able to write the correct syntactical examples for each of the addressing modes of 8051. Thank you.